Hello, so in today's class, we will look at the generalized principle of a proof of the generalized principle of inclusion and exclusion. So as we have seen, the generalized principle of inclusion and exclusion states that, so if you have an n element universal set S, and if we have properties P1, P2, PQ defined on that set S, then for each m equal to 0, 1, 2, etc. q, E of m will be equal to summation k equal to m to q minus 1 whole raised to k minus 1 kcm omega of k. So we have verified this using an example in the last class. So E of m is the number of elements which possess exactly m properties, and omega of m is given by summation over omega of pi1, pi2, etc. pim, where the summation is taken over, where omega pi1, pi2, etc. pim counts the number of elements which possess these properties pi1, pi2, pim, and omega of m is a summation over all such m combination of properties. So that's how we have defined E of m and omega of m. So let us look at the proof for the generalized principle of exclusion and inclusion and exclusion. Suppose for the proof, what we do is we will consider an x belongs to S. So take an arbitrary element x belongs to S. Now what we prove is that അപ്പോൾ നമ്മൾ x എടുക്കുമ്പോൾ x will possess a certain number of properties. So what we are going to do here is we have this equation. അപ്പോൾ നമുക്ക് ഈ equation true ആണെന്നാണ് കാണിക്കേണ്ടത്. E of m is equal to summation k equal to m to q minus 1 whole raised to k minus m kcm omega of k. So we will pick an arbitrary x belongs to S. So it will possess certain number of properties. So we will show that x will contribute equally on the left side and right side. അപ്പം നമ്മൾ ഏതൊരു x എടുത്താലും so E of m value must be equal to this summation. So that is how we do the proof. So we shall show that each x belongs to S contributes the same count so that is either 0 or 1 to each side of equation 1. So let us call this as equation 1. So let take x belongs to S. So let x belongs to x S be given, and let us assume that x possesses exactly t properties. So assume that x possesses exactly t properties. Now we need to substitute t into this equation. Not t, we need to now look at what is the value of the equation of the equation 1. So we have E of m equal to summation k equal to m to q minus 1 raised to k minus m kcm omega of k. Now here for a given m, so we will have 3 cases. So the first case is when your number of properties can be less than n. So t can be less than n, and now t can be equal to m, and t can be greater than m. So in these 3 cases we will look whether the inequality holes. Okay, so let us consider the case 1. So case 1 is when t is less than m. So t is strictly less than m. And now let us verify the equation. So E of m is summation k equal to m to q. Okay, let me write the expanded version. So that is omega of m minus m plus 1 cm omega of m plus 1 plus m plus 2 cm omega of m plus 2 minus etc. The last term is minus 1 raised to q minus m qcm omega of q. So we need to check whether this is satisfied or not. Now here we have E of m and we have t less than m. So let us look at the value of E of m for x. അപ്പോൾ നമ്മൾ എടുത്ത x possesses t properties. So x is an element which possesses t properties and t is less than m. And now E of m എന്ന് പറയുന്ന E of m is the number of elements which possesses exactly m properties. അപ്പോൾ t ന്റെ value m നെക്കാട്ടിലും ചെറുതാണ്. So therefore x will be counted 0 times in E of m. So clearly x contributes a count of 0 to LHS, and if you look at RHS, RHS നമുക്കുള്ളത് omega of m plus 1, omega of m plus 2 up to omega of q. Now here t is less than m and omega of m എന്ന് പറയുന്നത് that is the summation on all the m combinations. So your elements must possess m properties at a time. അപ്പോൾ t ന്റെ value m നെക്കാട്ടിലും ചെറുതാണ്. അപ്പോൾ all this are going to be 0. So omega of m will be 0. That means x will be counted 0 times in omega of m plus 1, omega of m plus 2 and omega of q. So therefore x will contribute a count of 0 to LHS and RHS. So therefore when t is less than m, it contributes equally to the left side and right side. Now let us look at the case 2. So case 2 is when t is equal to m. So when t is equal to m, so let us look at what is the value of both left side and right side. When t is equal to m, so your element x will possess exactly m properties. Okay, അപ്പോൾ x will be counted once in E of m. E of m എന്ന് പറയുന്നത് that will be the number of elements which possess exactly m properties. അപ്പോൾ x നെ നമ്മൾ one time E of m ൽ കൗണ്ട് ചെയ്യും. ഇനി റൈറ്റ് സൈഡിലേക്ക് വരുമ്പം in omega of m, so x is possessing m properties at a time. So in omega of m, x will be counted once and ബാക്കി വരുന്നതിലെല്ലാം 0 ആയിരിക്കും. So therefore it will be counted once on one time in E of m and one time on the RHS. So therefore it will contribute 1 on both sides. So again the equation holds when t equal to m. So in this case x is counted once in E of m, and on the other hand x contributes 1 to omega of m, but 0 to omega of r for r greater than m. So omega of m will one time count ചെയ്യും, and for all omega of r where r is greater than m, അതായത് omega m plus 1, omega m plus 2 and omega q, x will be counted 0 times. Thus x contributes a count of 1 to both sides. And now let us look at the case where t is greater than m. So case 3 is when t is greater than m. So when t is greater than m, so x will possess more than n number of properties. അപ്പം E of m ൽ x count ചെയ്യത്തില്ല. E of m is the number of elements which possess exactly m properties. അപ്പോൾ t ന്റെ value m നേക്കാളും വലുതാണ്. So x will contribute 0 to the left side. So now x contributes 0 to E of m, and now let us look at the RHS. So on the RHS, x is counted. ഇനി നമുക്ക് RHS വരുന്നത് we are starting with omega of m, omega of m plus 1, omega of m plus 2. അപ്പോൾ പോയിട്ട് നമുക്ക് omega of t വരും, then omega of t plus 1, so on. Okay, up to omega of q വരെയാണ് നമുക്കുള്ളത്. Okay, now here you have t greater than m. So from t you can pick m properties at a time. Okay, അപ്പോൾ x ഇതിൻ്റെ അകത്ത് കൗണ്ട് ചെയ്യും നമ്മൾ. സോ ഈ ടി സി എം. ഓക്കെ, അപ്പോൾ ടിയിലെ പോസിബിൾ എം കോമ്പിനേഷൻസ് എടുക്കുക. അപ്പോൾ ആ എം കോമ്പിനേഷൻസിനെല്ലാം ഇപ്പോൾ ടിയിൽ നിന്ന് നമുക്ക് പോസിബിൾ ടി സി എം കോമ്പിനേഷൻസ് എടുക്കാം. ഓക്കെ, അപ്പം അത്രയും പ്രോപ്പർട്ടീസ് അത്രയും പ്രോപ്പർട്ടീസ് എക്സ് സാറ്റിസ്ഫൈ ചെയ്യുന്നുണ്ട് അറ്റ് എ ടൈം. സോ x will be counted TCM times in omega of m. ഇനി നമ്മൾ omega of m plus 1 എടുക്കുമ്പോൾ we are taking the all the possible m plus 1 combinations. Okay, so you are counting the elements which possess m plus 1 properties at a time. അതിൻ്റെ എല്ലാം sum ആണ് എടുക്കുന്നത്. Okay, അപ്പോൾ from t you can choose m plus 1 elements at a time. Okay, അപ്പോൾ ആ പ്രോപ്പർട്ടീസ് എല്ലാം x സാറ്റിസ്ഫൈ ചെയ്യും. So x will be counted tm plus 1 times in omega of m plus 1. അതുപോലെ tm plus 2 times in omega of m plus 2. And here omega of t യിൽ x will be counted exactly tct times. And here it possesses more than t properties, omega of t plus 1, omega of t. So here it will contribute a value 0. So now let us write that. So that's how x will contribute to the right side. Okay, so let us write that. So on the RHS, x is counted TCM times in omega of m, t m plus 1 times in omega of m plus 1. So on TCT times in omega of t, but x contributes 0 to omega of r for r greater than t. Omega of t വരെ ഇത്രയായിരിക്കും കോൺട്രിബ്യൂട്ട് ചെയ്യുന്നത്. So for all values of r where r is greater than